Okay, so this is the 3-1 notes. These are pages 255 to 262 in your text, in your consumable textbook. You want to pull those out so that you can fill in the notes. The assignment, if you want to do it on the paper version, it's page 263 through 268, numbers 1 through 5, 7, 8, 10, 11, 13 through 17, and 24. Now, this is the alternative assignment to doing it online at HRW, which I highly recommend just do the online assignment. But if you're having problems, this is your alternate. Okay, so we're going to start looking at solving linear systems of equations. We're going to look at linear and quadratic first. Really, this is just find where they intersect. That's the whole point of finding the solution to a systems of equation. Where do the lines, where do the functions intersect? Okay, so we have a constant line. We know it's constant because it's going left to right at y is -3, and we have a quadratic. So the idea is how many different ways can this line cross that quadratic and get a solution? Well, we can have a line crossing at 1 point, we can have it crossing at 2 points, or at no points. So 0, 1, or 2 points is what is the possible answers. No solution, 1 solution, or 2 solutions. Okay, so with Desmos, with your any calculator, you can put in your equations, and then you would literally just look for the crossing points. So I'm going to switch over to Desmos, and I have put in our first two equations. I typed them in exactly how they were given to me, without doing the changes that they asked us to do on the notes. And we are simply looking for where do they cross. So their intersection point is 0, 4.5. That is your answer. That whole point, 0, 4.5. So at x is 0, y is 4.5, we have an intersection between these two functions. Let's see. So approximate point of intersection is at 0, 4.5, and we check that using our calculator. The rest of what this is showing is just different ways you can do it algebraically, which we are not going to do right now. We are simply going to use our Desmos. So speaking of which, I want you to go onto Desmos, go ahead and put in the two equations. Again, type them in exactly the way you see it, and tell me what your solution is. And do that for number 4 as well. Okay, if we were doing it algebraically, we would do all of the steps you see here. Again, I do not want you to do algebraically today. We will do those again later when we are actually working with quadratics. So do not do algebraically. I did fill in this one to see how you would do that, but again, we would use Desmos. So I'm going to show you how we can solve the two examples that they give us using Desmos again. So I'm going to take off what I already showed, and this is problem 2. So you have your line, the 3x minus y equals 7, and you have your quadratic, and notice they do not cross at all. So this one, without example 2, by using algebra or graph, we can say that it is no solution, because there is no place at which those two will cross. Again, do not do this algebraically. So I've shown you on the paper how to do it algebraically, and now we will do it with our Desmos. So we put in our two equations, and you notice that there are 2 points at which it does cross, and that is at 5, 1 and 7, 4. So that would be our two solutions. So what they're showing is that you can use substitution, solve down to get your x's, and then you would substitute those 5 and that 7 back into the original equation to figure out what your y's are. Again, we are not doing the algebraic. We are simply using Desmos. Please don't try to do this by hand, not until we're ready for it, okay? Okay, so again, 2 more problems to practice with Desmos. And what are the solutions to these two? Okay. We can do the same kind of problem with word problems. They give us our two equations, and we simply stick them in and find out on Desmos where do they cross. So let's look at this example. A signal from a radio station can be detected up to 45 units of distance away. Taking the location of the station at 0, 0, a stretch of highway is modeled to be y minus 15 equals 1 over 220. And we want to find the radius. A radius is found by using the circle function. So they use x squared plus y squared equals the radius squared, and that's the two equations that they are using. So again, we can put this into Desmos. And after zooming out just a bit, I got to put the equations on there. We see the radar is right here at the center. And this is the arc that the radar would make as it turned around and around and around. Where does it cross the road? Well, it crosses the road at negative 43.128 and 12.844 and 41.632 and 17.082. So that would be our 2 points that it is going to active between. So between 41.63 and 12.84 and 41.63 and 17.08. So if you were working in a job where you were trying to figure out a radius of area that something could be going on, you know that your radar is going to detect whatever's going on in this particular area. That's where you're going to receive signals. So sometimes when you're driving your car and you happen to not get a Wi-Fi signal or cell phone service, this is the reason, because between a certain point and a certain point to point, is where the signal is being actually received. Outside of that, it's not the broadcast range is not enough. Okay, so I want you to do number 8 and number 9. And again, simply use Desmos. Okay, so that is all of 3-1's notes. We are going to have a 3-1B, which will look at something that is not in the assignment, but is something that we will be testing over. So I want to talk real quickly about that. This is actually just finding linear systems when you have two variables. So something like x plus y equals 3 and 2x minus 5y equals 4. So when you have this situation where you have two variables, you have to have two sentences to solve so you can find out what your x and your y is on both. Now there are two ways that we can do this. One of them is called substitution, and one of them is called elimination. Substitute. So I'm going to demonstrate this problem using both of these types. Okay, so first we're going to do substitution. Substitution is really easy. You basically solve one of the equations for one of the variables and then substitute that into the other equation. So I'm going to take this equation, x plus y is 3, and I'm going to solve for y. I could have solved for x. I'm just going to solve for y. Now we're going to take that new solution for y, and we're going to substitute it in to the y itself in the second equation, and then solve for x this time. So basically, you solve for a variable, substitute it into the second equation, and then solve. And let's see, 7x minus 15 equals 4. Add 15 on both sides. And of course, I don't get anything really pretty. Once you've got your x, now we substitute back into one of the original equations, and I usually will pick the first one instead of the second one since I used the second one to figure it out. And we're going to do 19 over 7 plus y is equal to 3. It's 21 over 7 minus 19 over 7. So y is 2/7. So the solution to this problem is 19/7, 2/7. Okay, so that is using substitution. Now we're going to do elimination. So I'm going to recopy the question on the back on the next page. And we're going to do the same problem again, only this time we're going to use elimination. Elimination means that you're going to try to eliminate one of the variables so that you can solve for the other one. So the question is which one would be easier to get rid of? Well, I've already got a -5 here. So if I multiply the top piece by 5, I'll have a 5 minus 5. The idea is that you want to add down to get 0. So we're going to take the top piece and multiply both sides by 5, rewriting it to be 5x plus 5y equals 15. I haven't done anything to the second equation, so all I'm doing is rewriting it. Now we add down. So 5 plus 2 is 7x. 5 minus 5 goes away, and we get 15 plus 4, which is 19, divided by 7. X equals 19 over 7. Okay, so that's that. If I wanted to do the other direction, x plus y is 3. 2x minus 5y is positive 4. This time I want to substitute and get rid of x so I can find out my y. So I need to add something to 2 to get that to go away. So I'm going to have to multiply by -2 all the way across. So -2x minus 2y is -6. Again, the second one did not change because I didn't need to make any change. Sometimes you have to change both of them. So -2 plus -2 goes away. -2 plus -5 is -7y. And -6 plus 4 is -2. Divide by -7. So y is 2/7. So you can see either way we get 19 over 7 and 2 over 7 as our answer. So again, the first way is called substitution, where you solve for one of the equation variables and then substitute into the second equation, and then substitute your answer into the original first equation to get the y. The second is called elimination, where we basically change one or both of the equations so that we can add down and eliminate a variable, then solve for the other one. And then we can repeat that, or I could have taken that 19 over 7 and put it back into the original equation and solve just like I did step 2 on the original. I just like to show it in multiple ways. Okay? That is all of the notes for 3-1.